For the next several problems, we're going to try dominant terms. So I'm going to be taking the limit as x approaches a positive infinity and the limit as x approaches negative infinity. Now when I do that, I have 2 times, for this first one, infinity. 2 times infinity plus 5 is infinity, and then you square infinity, that's infinity, times 3 plus 1 is still infinity. So I'm getting infinity over infinity. That means, and I can use dominant terms. So I'm looking at the highest power of x in the numerator and the highest power of x in the denominator. And I'm going to simplify that. The 2 stays, the 3 stays, but one of my x's cancels out, so that leaves me with an x in the denominator. Now I'm going to reevaluate the limit. 2 divided by 3 times infinity. Now I know 3 times infinity is infinity, so 2 divided by something really, really large is really, really small, so 0. If I plugged in negative infinity, okay, my x's cancel out here, and I just have numbers on the end, so I'm going to get the same ratio, 2 over 3x. Well, 3 times negative infinity is negative infinity. 2 divided by something really, really large in magnitude is really small. It happens to be negative, but it's still really close to 0. So if I just had to take my limits, my answer would be 0. My asymptote is at y equals 0. For this next problem, 2 times infinity squared is infinity, plus 5 is infinity. 3 times infinity squared is infinity, plus 1 is still infinity. So again, I have infinity over infinity. So I would be doing the limit as x approaches positive infinity and the limit as x approaches negative infinity, but I have to do dominant terms. So the dominant term in the numerator is 2x squared. The dominant term in the denominator is 3x squared. That reduces to 2/3. Now remember that you only do dominant terms if you're headed towards positive or negative infinity, at no other time. Well, if you take a limit as x approaches anything of 2/3, you're going to get 2/3. Positive or negative, it doesn't matter, so 2/3. So these would be the limits if I'd been asked those. The asymptote is at y equals 2/3. Now this problem is a little bit more interesting. This is a rational function of polynomial over a polynomial, rational function of polynomial over a polynomial. The ratios are going to work out the same no matter what, but if you look at this one, and I look at dominant terms, I should back out and actually plug something in, but I'm going to have infinities involved all over the place again. There's a couple of different things about this. I have 3x divided by the square root of 2x squared. A lot of people, they'll recognize that the square root of x squared is just x, but they try to write it as, well, then my x's are going to cancel out and I get 3 over 2. But that's not true. So this square root of 2x squared, that is equal to the square root of 2 times the square root of x squared. This cancels out and we have an x, but then I still have my square root of 2. So what's happening here is that if I just totally ignore this, I would have 3 over the square root of 2. But there's something to be said about what's actually happening with your x's here. So I'm going to do the limit as x approaches a positive infinity and the limit as x approaches negative infinity. Now I'm actually going to write this part down. I know that I'm going to get a 3 over the square root of 2 for both answers, but I want you to see this, what's going on with it. Okay, 3 times a positive infinity is positive infinity. Positive infinity squared is positive infinity times 2 is still positive infinity, and the square root of that is positive infinity. We've got nothing strange going on, so I would cancel out the x and the square root of x squared, and this is 3 over the square root of 2. No problems. But if you look at this, if I plug in negative infinity, 3 times negative infinity is a negative. Down here, I'm squaring it. So negative infinity squared is a positive infinity, times 2 square root. This will always be positive. Now it's a little bit more interesting. So I have a negative divided by a positive. The x's do cancel out, but I still have to consider the signs. So this would actually equal negative 3 over the square root of 2, which makes you wonder, do you have to do that here? Well, if you look at them, the signs aren't going to matter, right? Something positive over something positive, no matter what, because these are squared. If you look at this one, let's say that I plug in a negative infinity. Well, then the top will be negative and the bottom will be positive, but it's still 0. It doesn't really matter. For this one, it matters. So there are two asymptotes, y equals 3 over the square root of 2 and y equals negative 3 over the square root of 2. Okay, we have a few more problems. Okay, so looking at this problem, I have infinity cubed plus 5 times 2, all of that stuff. We have infinity over infinity again. So I'm going to do my two limits. And I'm going to look at my dominant terms. So I'm going to ignore the 5 and the 1 and look at this piece of my function. Now it does simplify, cancel out, so I'm left with a 2x over 3 for both of these. And we're going to plug in positive infinity first. 2 times positive infinity is positive infinity divided by 3 is still positive infinity. And it should make sense to you that the bigger expression is in the numerator, the dominant one, is x cubed over an x squared. I'm headed out towards infinity. If I plug in a negative infinity, a negative times a negative times a negative is negative, and then down here I have a negative squared is positive. It's going to be a negative over a positive. If you look, everything's fine. 2 times negative infinity is negative infinity divided by 3 is negative infinity. So as you head towards the right on the graph, you're approaching a height of infinity. Towards the left, you're approaching height of negative infinity. That means you have no horizontal asymptotes. Your limits would actually have to be approaching a number, and infinity is not a number. Now, this next problem is interesting because you've got a sine x in it and an x. There's no algebra you can do to simplify this, so we're just going to write down, okay, what happens if you do the limit as x approaches positive infinity? What happens if you take the limit as x approaches negative infinity? And what you have to start thinking about is the size of things. Like in terms of dominance, which function does more, which is greater. So as I head out towards infinity, I know that this x is going to head towards infinity. I know that this x is going to head towards negative infinity. But what's happening in my numerator? So let's say we're going way out on the far right-hand side of the sine graph. Sine is cyclical, so it's going to keep going up and down and up and down and up and down. Now, the truth is, I don't really care where you check. You can check at x equals 10,000, x equals 10 million. It's still going to be looking something like this. Well, this just is not that big. This is a total distance of 2. You're going from a positive 1 when you're at the peak, and you're at a negative 1 here. Think about the size of that over an infinity. So anything between negative 1 to 1. When you divide it by something that big, you're going to get something that small. So it's 0. Sine here out towards negative infinity is doing the same thing it did towards positive infinity, so we have again a negative 1 to 1. And the sign really doesn't matter because we're still getting something that small. So our limits are both 0, and y equals 0 is your horizontal asymptote. And I added this problem in simply because I'm worried about different mistakes people make. One thing that's happened is identifying dominant terms. Some people look at the first terms, and that would be wrong. Now, if you did, the infinity is on the bottom because there are no x's to cancel out, which would mean that the asymptote would be y equals 0. But if you actually really look at the numerator, you can see that the more dominant term is right here, the higher power of x. So it might help you to rewrite the function it's negative x squared plus 2, like make sure your polynomials are in order in terms of degree, over 5x squared plus 6x. This is your new function. So if I'm looking at my dominant terms for this, if they're written in order, I can circle the first two terms, and that reduces to a negative 1/5. So either way, whether I approach this function as x approaches positive or negative infinity, I'm going to get a negative 1/5, and that is the asymptote.